Chat and member list. Okay, so last time we have finished mostly our user mode TCP class, which allows us to send packages in a reliable way between two endpoints and have a mechanism that takes care of resending missing packets. And today we will try to improve on that and test what parameters we could tweak to make the transmission as efficient as possible. So first we will create a new project which will be Qt based so that we can add some UI components. What we want to do is we will want to plot a few graphs and have a few sliders that allow us to tweak the parameters of the communication in real time so that we can see what we are doing. That should be quite entertaining and also educative. So create new project, Qt widgets application. Next, let's call it Q user mode TCP. Oops, that was the wrong key. Right. Okay, class name. Okay, so our new project is ready. So let's add a folder and then we can copy from our old project the files which we have already created. Actually we could copy the whole thing. Now we copy just the whole thing and then we will remove whatever we don't need for this application. So we don't need this, we don't need the project files. We will not need the main, but we can leave it at least here in the folder physically. This we need, the test files we need as well, the headers also, so let's add those files to the project. We might need to disable, we definitely need to disable precompiled header on those few files since we have enabled that globally, but here we don't have this enabled. Precompiled header. Not using precompiled headers. Okay. And let's quickly compile it to see if everything builds as it should. Okay, we are missing some libraries. We forgot to add them. Link input. That's what we are missing. Suck. Okay, with the Winsock library it should now compile. We didn't have any other errors except the missing library. Okay, perfect. And one more thing we can do, we can quickly open our old main file and integrate it into our application so that we also here start everything up properly. So let's go with this. We will need to include Windows H. That might actually conflict with Qt. We will see if it conflicts or not. If it does, then we'll slightly change the way the code here works. Okay, we can, yeah, we get this. We don't need to wait since the exec call on Qt application will be logging anyways and return 0 since we need to return something. Yeah, let's see if that compiles without errors. Okay, that worked fine. We just need to load a few debug symbols and then we will start creating the UI for our test setup. Also, any printf messages, since we don't have a console, should be ending here in this log. Plus a lot of other debug messages, but for now we don't have any. Did we intend that there are any? We should actually see something coming from the test client. So quickly let's see if the test client is still working properly. One break here, one break there, and one break there. Okay, so as you note, so last time we have finished the class such that we have basic functionality. We don't have good congestion control and anything, but it will resend lost packages and it will send as many it will send our data stream packed in packages to the other end. And what we want to do is today we want to create a UI element, well, not element, a whole UI infrastructure where we have a plot where we can plot different parameters of our connection, and then have a couple sliders or edit boxes where we can change connection parameters. So for example, that we can change the window size, meaning the amount of packets that can be on route before they need to be acknowledged. We will be also able to change maybe timeout values and other parameters. So the idea is that we will see graphically how the communication protocol behaves in a synthetic test. And we will see how far we come with that. If we finish implementing the UI part, what the next thing to do would be to run it onto different machines to see a more real world scenario of how the mechanism works. Okay, so let's continue with that. Okay, it seems it's working, but it is not printing anything to the output. Could be in this case we will need to fix that. Well, we can do two things. First of all, we could reopen a console, which is a valid solution, or we could try just to connect to the just to try to reopen the standard I/O ports. That should work probably as well. Let me think how to do that. I had somewhere an example of doing that and it worked usually quite well. So we only need that code. So we go back to our main function. Before we do anything, we will first of all we will check whether we can attach to a parent process's console. And then if we cannot, then we'll create a console. If we can, then we're already happy, and then we'll reopen the console's data streams. If that should work, unless it complains because of an include. Yeah. Okay, so let's see, send, receive. When we do the printf, nope, it still doesn't print. I mean, we could just switch the printf to use QDebug. I guess we will go with that. But I'm surprised that it didn't work. I mean, we could just always force allocating a console. then we would just have an additional output console, at least for the beginning. That could be a acceptable solution. Okay, zack, zack, zack. And here it works. It might be that the Visual Studio is somewhat interfering. So normally, when you are setting up a project, in the linker options, how was that system? You can select the subsystem you are linking for. You can select between various which we don't need, and of course Windows which we need, or console. And if you use console, then the created binary will have a flag set that once it's started, Windows will automatically allocate a console for it. But of course, since we want this to be a UI application and we just wanted to see the output for now and not permanently, we'll stay with Windows, and instead we will in main allocate the console manually and then reconnect the output streams. This would definitely work if you would be starting the program from an own console, but apparently when running in Visual Studio in this particular configuration, this trick doesn't work, so we'll just use the simpler approach, which is fine. And now we can take a look on our Qt part. So there are a few things which we will need for our UI. As you may remember, I showed you at the very beginning of our lectures the UI creation using these UI files, where you really can just put elements once it's finished loaded wherever we want. We can either use this mechanism or write everything by hand. Which one we will do, we will see later. But what we definitely will need is the QWT library, which will allow us to create graphs and plots and more complex UI elements. So let's just go here, and we will add the library as an additional project to our current project. And I have somewhere already a precompiled version of that. There it is. So we will not need to rebuild it again, I hope. Okay. Copying may take... doesn't want to copy into the file, emits too many files, I'll have to zip it. Will just take a second. Add to archive. And zip. Now, the QWT library can be found on SourceForge, I think. QWT. And it is LGPL licensed, so it can be used in pretty much any project you might want to use it. The only restriction is that if you change anything to the code of so that too. First of all, you need to provide the library as a DLL and not statically link it to your project, unless your project is itself LGPL or LGPL compatible. And if you provide it as a DLL, you can either use it as is without any changes, or if you do any changes to the original code base, you need to provide the source code of what you have changed. So it's not a very strong limitation. It can be used in commercial products as okay. Then it's but normally copying large files might be also because I did not reboot this VM in quite some time. Okay, I will move that out of the shared screen for a second and get the file another way. Maybe it's because of that. Normally copying and pasting files into the VM works just fine, but sometimes the mechanism fails, and then the only way to recover it is to fully reboot the machine, what is something that one might not necessarily want to do during a lecture. Since when you reboot a Windows thing, it might then want to install some updates, and then it will take forever. Okay. Now it's copying the file. As it should. Let's and unpack everything. I think it was already the folder. The zip is quite big because it's like really just a compiled thing as is, with all the debug files and object files and all the stuff that normally is not needed. So if you just want to redistribute an own copy of the binaries, then that could be much less. Okay, that is slow. No, that is not acceptable. We need a faster way of doing that. Don't we have 7-zip on this machine? Actually, I was thinking that normally the copying really works quickly and without any trouble, so I have not prepared that. I just assumed it would work as it works always, but now apparently it does not. So let's get 7-zip. Managers. 7-zip. Which one is the newest? This one. I hope that at least pasting 7-zip will work. Yeah, with small files it works fine. It just is a too big file to properly copy across the virtual machine. 7-zip extract here. Yeah, that is much faster. That is what I would expect. Apparently the unzip routine of Windows 10 is quite bad, since it wanted to take half an hour to unzip what 7-zip can do in under a minute. But well, that's why we use third-party tools for almost everything. Okie dokie, so unpacked. Here it is. Here we have some other DLL. No? No, this is just it should be done here. Yes, there it will be. By tube. This is just the object files. Okay, we have the lib. There is some other DLL. One moment, please, because we will need to copy the DLL into our output folder, or to the system directory, which well is not so nice. So I would not recommend nowadays installing anything to the system directory. Just always go with installing whatever files you need directly to your application folder, even if that means that everything will be bigger, because you will have redundant files. It avoids issues with different file versions when they still have the same file name. So for example, Qt changes the file names only between major builds, but they don't change. They do not change. That should be there. But they don't change the file names. Okay, so qvt Win32. Did I compile only the 32-bit? Okay, then we need to compile the 64-bit version. We only have the DLL. This is strange. It should be for both. No, it should. I know what I did. I just I copied and moved the DLLs around. That's why they're not included in this zip. Great. But they are small. They should copy just fine across the VM boundaries. So first we need here the debug DLL for x64. So this is this one. Damn it, that didn't work. But so it doesn't work. Not cool. One moment, please. I will upload the required files once they are pre-selected to the Moodle, so you won't need to download large amounts of megabytes. But I wouldn't have not expected that there will be so many troubles with just copying a larger file to the virtual machine. As I said, that normally works just fine. Since we don't use 32-bit, I will for now just stick to have the two DLLs for 32-bit. Sorry, for 64-bit. So they are just normally located here together with the lib file. What point do I actually have the lib files here? If they were copied around, maybe they are gone. By type, yeah, the lib file is also missing. Damn it. By now, it probably would have been faster to recompile the whole thing directly. But since we like the sunk time fallacy goes, once you started and invested enough time in a mistake, then you have to make it work. Okay, so we will get the lib. That's the was the debug one. Okay, so we need to go to the directory. No, it's there. Damn it. Wurscht. So we have the lib. At least the one for debug now here. This one file we need, and the other file is, as said, the DLL. Okay, now we have both here, so we can copy them and move them to our project folder. Mount QVT 64-bit debug. Okay. Then we will add the just copy one. Why that? Okay, now we have copied everything. Somehow the Windows instance is really buggy. I really should reboot the VM before the next lecture. Okay, linker input, our configuration. Here we add our QVT lib. Let's see if it compiles or if it needs some additional path includes. So you can configure folders in which it will look for libraries, but normally I would expect it that if you put it into the output folder, okay, but the expectation would be wrong. It would find it, but it didn't. So normally where would we be? With something like this, x64. Where we are now in the debug case, so this will need to be changed for the release case. Okay, and I think it's one folder up. We will see if that's right. Yep, now we have the right include folder. And now one more thing we will need is we will create two new files, which will add a nice graph for us. Add a new item. Yeah, CPP file, and we call that incremental plot CPP, and a new header, add new item, incremental plot H. Okay, now I already have these files finished for another project, so we'll just copy and paste the content here into this one and see if it compiles or if it will complain about something. It might complain since the file was made for Qt5 and now we are using, I think, Qt6 here. And okay, we need to write, I think we are just one directory up. Jawohl. Okay, why is it complaining here? No, it's fine. Qt label. Actually, I probably just should look for the update. I somehow have the updated file as well. One moment, please. Where did I put that? Help us. Since it's complaining already here at a couple places, I think the new version we have will benefit from an update. So this is the newer version. Oops. No, that will. No, that might. It's not the newest version. Damn it, where did I put that? Projects. And this is also old. T6. Scale pass common. I have this here. Nope. Then it's in the main project. Somewhere. Common incremental plot. Yes. Okay, this version should be Qt6 compatible. We also need to update the header file. Okay. Yes, and here we'll quickly replace the include location. Replace R. Damn it. Normal H. This with that. Replace all. Okay. Now it worked. And let's compile it. So what the class does is it creates a plot where you can add single data points, one after the other. And normally the QVT plot just takes a list of x and y values. So here the x values are automatically incremented, and you only need to provide the y value. Okay, we don't need this, I guess. Byte scale. Oops. Byte scale is the scaling which we will not be using. And time, or was it complaining about time? Time is something we actually might want to use, but for now let's just ignore that. No, we cannot, we will need that. I can do it differently. Q time, Q date time, Q date time. No. What is current date time UTC to UTC, and this gives us that one. This gives us the time in milliseconds since the start. That is good enough for the time axis. Okay. Nice. So now we can go to our UI and we will start with a grid layout. Normal grid. How it worked. We will set this as our default layout, and we for the beginning we'll just want to add our incremental plot and test it somehow. So since we cannot add easily custom Qt elements, we just add the empty widget here as a placeholder. We'll call it plot widget, and then we can add a few things. So let's add just a button that does something. And since we don't want this to look this way, we will add here. Damn it. I cannot position it so easy. But here it's somehow no. Okay, for this one it worked fine. But now we have 2 rows, so we can put the button. Now it's okay. Let's leave the button. I pressed the button wrong. I usually try not to use this graphical thingy because it's kind of messy, but it's much faster than writing everything by hand. It's just a bit annoying. Aha, now it worked. So we can draw, pull it around. Pull it also the wrong English word. Doesn't matter. Extend it to use 2 columns. So one column has a expander, and the other column has just a push button. We'll call it button test. We can give it also some text. Run test. Call it run test. Okay. We can now save that, and if we run it, it will just show us for now an empty window with the button, and then we will start adding functionality. Yes? Well, currently both sides are just in one process, but the window is contained in that process, yes. But I just run into another problem. Apparently our QVT library has a different version than the Qt we had running, which is not good. So we will need to recompile it. I was hoping we could avoid that since that takes time. But apparently we have to do it. The problem with Qt is that they often change things, and unless you have the exact right version, then you need to recompile everything with the new, or for the platform that you are using. So let's see if everything is set up properly. Okay, no, of course not. We select everything and everything. Here we need the 2019 version still. And then if we go to the Qt project, we will select for all of them the only version we have. The rest should be fine. Build. Okay, let's just go with debug 64-bit, yep. Rebuild solution. I wonder if we could have built that also with 2020. It probably would be even compatible. So actually we could abort this and try 2020. In the very old versions of Visual Studio always needed the same version, but they changed that since I think 2017, that all the different versions are more or less binary compatible, so we don't need to So you can load the library compiled with 2019 into a project compiled with 2020 and vice versa, which is quite nice actually. That will unfortunately take some time. So while this is compiling, we can already proceed here by with in setting up the other things. Well, blindly, since we cannot test what we are doing. We have here our main file which contains the UI and UI punct sorry, should be punct. Okay, then IntelliSense doesn't work. That is of course it just needed time. What was it? Plot widget, I think I called it. Yes, plot widget. That thing has a layout. So, oops. Top. Oops. Yeah. Replace widget. Plot widget with widget to replace with. So we will need to make a new one. We will include here our incremental plot. Actually, let's use incremental plot. C incremental plot asterisk p increment p plot. Press new incremental plot. Why is that complaining? It needs to be a C incremental plot, of course. I think it doesn't need any parameters, so the defaults are fine. We'll stick with those for now. And just for good measure, we can replace the pointer here in case you want to refer to it later. Although this is now just type widget, so we would always need to cast it on type incremental plot if we use this. Or what we also could do is we just go to the header of our file and just add it class C. Is it not working? Here it is, incremental plot. Mpan plot, and then just use this directly here, and just for good measure set this to null, so that we don't try to use something invalid if we would be doing something stupid, which can happen. Okay, so this is added here. The next thing, we will want to create a slot for our test button. Void on run test, or just run test. Let's call it run test. Okay. Connect. UI.pt button test, comma signal. What was it? Pressed with this slot run test. Let's see if the compile finished. It's still compiling. So why is that complaining? I forgot the asterisk. I wanted that to be a pointer. Okay, so that should be fine now. We have our run test, and what we also probably should add would be some timer. It's always useful to have some helpful timer in the project, which can be used to do something. So let's see what we need. So So let's add a the header file that it is. We should just pin the files that we need most so that they're always at the same place. Protected void. I think it was void. Okay, this takes too long. How was it called? Tml event q wurscht. Let's make everything look nice. I have not yet planned what we will use the timer for, but I said it's always, maybe not always, but it's often good to have one. Okay, something's hanging. I think the I think the VM did not like copying these large files around. It seems to be slightly broken. Okay, so we need if timer is not equals per timer. It should not be called per timer, we should call it per event. Zack. Should have some timer ID. Yeah, so if this is not the same, then I'll return. So we could in principle have started more than one timer. It's good to have this check, although of course if we would know that we only start one, then let's run it 10 times per second, and here timer ID to stop it. Let's see if we are done with compiling our QVT. Yes, we are. Okay, so let's go there and copy the new required files, sleep and DLL, back to our folder here, and then let's run it again. And when it works, and when this will work fine, I'll just start compiling the release build in the background in the meantime, so that we have both in case we want that later for something and don't want to wait. Okay, everything linked fine. This is our console which we created. Okay, this didn't work out. Why? The layout was null pointer. This doesn't have a layout. Okay. That should be parent layout. Parent widget layout. We had this, I think, when I was showing those mechanics the first time already, that I forgot that it's a parent widget's layout we need to address in order to replace the widget properly. Okay, that is not quite right. I mean, it worked, but it didn't plot anything. It should actually show an empty box. We will check that out, but for now let's... So it should have showed like a graph, but without data, but already with the two axes and tick marks on both ends. But for some reason it didn't show anything. Perhaps I forgot to initialize something. How was that? It's always useful to prepare things up front, but sometimes I just think it will work out quickly, and then I forget how much work there might have been setting those things up for the first time. I think we need to at least tell it how many things it is supposed to show. New incremental plot. Need to be found quickly. So what do we need to set up? We need to set limits, set text color, the plot limits to be careful though. That should not be. That should work without setting explicit text color. What else? Okay, we need to add a plot. That's of course a good point. Add plot. Give it a name. Let's call it test. And the rest and the color Qt. Let's go with gray. Style Qt solid line. Okay, and the rest should be optional. Okay, it's thinking. I think I should just disable the debug stuff for now. It just wastes too much time. General symbols. Yeah. Okay, so okay, that is not quite right. I mean, maybe I need to set all the colors. I thought that the way it was created, it was supposed to not need any colors and just work fine, but let's go with, let's say the background should be black, Qt, because gray on gray of course will be like nothing. So I probably somewhere have set the wrong default colors, and since normally I use at least some customizable color scheme, that didn't become an issue until now. Still loading too many symbols. I'll just disable the symbols completely for now. Okay. Yeah, we need to set all the colors. That's not great, but doable. Can we disable everything for now? Okay, so background led to dark blue. Front, let's make Qt white. Grid, let's make, okay, everything was by default transparent. Qt gray, light gray, no, dark gray, just gray. Let's go with gray, then we see where we go from there. And that's it. Okay, for the test, let's then use something, I don't know, blue. No, blue, we have blue is stupid. Red or green. Let's go with red. Okay. Well, at least it starts. It still starts slowly. Yeah, because we have all the symbols probably cached already, so it just loads them from disk. But now it looks nice, so we can do some simple test function. Let's go to protected ball. mb test. Okay. Initialize it to null. to false. And we could make the button checkable. Set true. Actually, when we do it checkable, then we don't actually need the value. We can query just the button every time. So this is just to demonstrate how to use this plot mechanism. So if UI btn test is checked, so if it's checked, then plot add plot point, and we need to give it the name, which was test, and the value, will be just just rand. Just go with a random value, we don't care. That will be quite fast since it will be updating 10 times a second. Did it work? Something's not working. Why? Ah, shit. That was supposed to go into the timer. We of course want to do the operation every time we repeat the timer process and not just once. No, something's not. But it is pressed down. Let's see, the timer is also working. Did I call it? Ah, capital T. Typos, too many typos. The good thing about C++ is that except for string constants, typos won't compile. With JavaScript or some other languages, if you have a typo in a variable name, it will just ignore it and assume it's a new variable, and then do something nonsensical. So of course it's just random data, but because it doesn't look like 10 times per second, does it? Let's see what's the CPU usage saying. Doesn't look like it's using too much CPU. Let's try doing it faster. Let's go with 100 times per second. And what we can also change is that we can set it up such that we will not refresh the plot each time we change one value, but okay, but this looks consistent. It was just for my eye too slow, but it apparently is. Now something sometimes when something is happening, then it becomes slow, but if we don't do anything, then it's reasonably fast, and we can of course stop it at any time. What we also can do is I have to check whether I added that function that we can add more than one data point at a time, but I don't think that it's included in this version. And the plot points, we don't have add plot points, no. So let's add that quickly. Oh, let's add it later. For now, let's just go with this. Okay. So this we can comment out for now. And what we'll want to do is we will want to plot some data that we get from our socket. So how do we access that? So we have the server. The server is just receiving data. The test client is sending things all the time, and the test client is dropping from time to time a package. So what we will want to do is we will want to monitor data from the client side. So maybe for good measure we will add here some debug functionality. Testing stuff. Or let's go with an integer int. debug drop packet. Yeah, rate. No, it's not rate. Probability. It's a long name, but why not? So by default that will be 0, but if we set it to not 0, then so if yes, drop packet probability, then if the packet wasn't sent yet, okay, we can remove this. So if it's also not really probability if we just do it like this. Packet, how do we call that best? The book drop packet modifier modulo, that is good enough. Okay, so the higher the number, the less likely it is that it will drop a packet, and it of course needs to be from M. And what we will also want is we will want to, for the beginning, log the window, just the window size, and we will want to log it every time something happens, or every time we send a package. Let's log it every time we do try send. That sounds reasonable enough. So debug log debug log window, and what we also want to do is we need to save somewhere the data. So let's go with std list. Oops. I think we need to include list. We haven't included list anywhere. That's why it suggested something else. So std list. What was our window? Oolong. Congestion window. Or I don't know. We will go with the pending block window size. No, that's wrong. That's the package on the network. The congestion window size is the right one. We can log a couple window sizes. So let's so M congestion window log. We don't need the M since good enough. Okay. Try send. Was it try to send? It was try to send. Try to send if M log congestion window, then M congestion window log push back M congestion window. Okay. And now we need some mechanic to get a pointer on our, and we need something to read that, of course. We need two things. We need first some mechanic to get a pointer on our test client's socket. And we can do it quite simply. We'll go here. We need to include that since we need to know the type. And we can just define a client test socket, and then we just assume that it's there. When you go to our client and create a socket, we write term, and this is equals client. So this will set up for us the variable. So this is how we can get on it. Here we can check if this exists. So if it's null, then we return. If it's not null, then we do something. That's more or less the same thing, but it looks nicer. And then we will need some mechanism to access all those well, to actually two things: to set the logging and to do three things: set the drop rate, set the logging, and then retrieve the logging. But we don't want to pollute our primary object definition with too many debug helper functions, so let's go with something like set debug option. We'll just give them names, and we need a value to set it to. Let's assume that will always be an well, either an unsigned int or just an int. Let's go with unsigned int. Long option. We probably should have a getter function which returns us the value, and then we need something to get the data. And we could of course assume that the data will always be a list of oolongs, which probably will be good enough for our application. So all get debug data. Okay, we should call it name, maybe. Name, comma, the list. Okay, in this case we need to include list already in the header to ensure that it's always available. So the list reference data. Okay. So with only these three functions we should be able to implement all our debug functionality. With those debug stuff we don't need to care that much about performance, since in normal operation we are not supposed to use those anyways. Okay, so if is this included? This is included. Nice. String compare, comma. How did we call that? Mod drop packet mode. M. The drop packet mode is option. That's and else. So return false if the name was invalid, return true if it is fine. And with the getter we will not have a explicit error message, we'll just return the value or 0. We could also return -1, but I think we don't need to care about that. I mean, it's just for debugging, so it doesn't need to be very error tolerant. And of course here, the same mechanic as here. And we need one more thing. We need a mutex or a critical section. Section log. Debug log. For now we will leave that for now we will do it like this, but ideally we would not want to even initialize the debug log if we are not using debug features, so that will need to be improved. Plus I just saw that we also need to set a secondary parameter here as well, since it's a log window. average 1 and 0. Okay. We don't need else since it's a return anyways. Okay, so here we have this. Yeah, in principle, if it's not enabled, then we should also return here an arrow. But if it is enabled, then m log. That's not the right name. What was the right name? Congestion window log was the right name. Punkt. First we need to swap. So what this thing does is it replaces the content of one list with the content of another list. It just swaps the content. So we will always need to enter with an empty list, and then we'll get whatever is currently in the log. What was it? Log. And we need to use our locker here. And of course, whenever we fill this, here we need to lock this as well, since these are running in different threads. As soon as we exit the scope, the lock is released, so this is fine. We will not lock any operations on these flags, although we should probably then declare them as volatile. Okie dokie. That should be good enough. We have the type, and so now we go with first of all we need start test here. So well, if this is not, then return, and if this is, then set debug option, and we will not need this to be checkable for now. How did I call that? Drop package mode. So we definitely want to start dropping packages at a rate of 100. And then the other one was log window. We will need to set to 1. We need to set this to 1. Okay. And here get the book data as to the list ulong and the log, and we then need the name. The name is wrong. Log window. It should be called window log. Yeah, it's fine. It's fine. Log window it sounds for a true false variable fine enough, and window log sounds for the log itself reasonable. And then we even have not conflicting names. That's good. Okay, and of course, if this is true, because it might be false if it was not enabled. And now we will need to add the plot points to our test plot. Just that we should really create a add points function so that we can add multiple points. Well, yeah, q list add points. Okay. I mean, the cheapest method, of course, is just to add all the points one by one. But I think we should maybe do it slightly better. Plus, this works with time, and we don't want to use time here as a timestamp. So we will. What can we do? We have the size parameter here. What's the default limit? 300 entries, that is not enough. Let's increase that. Set limit to 3000. That should be enough. But we have the limit, and we have a counter. Why do we use it somewhere? I'll just use timer counter. Yeah, so in principle, if we set use state to false, where is it? Initialize use state, unit state. Okay, but we only do that in legend, but we don't want to set a legend for now. It should be initialized to something. It's initialized to false. Okay, so actually that's fine. Well, for a quick swap samples. Let's copy this whole function for now to our add samples. Okay, so we check whether the curve exists. We check, we get the curve element. Here we check whether we are already at the limit, in which case we would. Sorry, we check if we are below the limit and need to add more points. And size just plus plus, and this should not be plus plus. This should be then plus equals size. Or in this case, here not plus 1, but plus equals size. Wait. Move. It only moves everything by 1. We want to move it by however many we have, and we don't need to move the things that we already have. So this is okay. Now here we would and set this, but we don't want to do that. Okay, let's go with this. For this part we will do in the loop. That should be called values then, of course. Values. So this will now complain here and here and here and here and here. Values. And then we add value each time. That looks reasonable. Then we update the data and then we issue a replot. Okay, so this is done. So now the only thing we will need to do is to convert from a std list to our qt list list of values. Let's go with values. Q list double list for auto e is equals when the log begin and sharing e plus plus and list append asterisk I. Const list by reference, that should be fine. Q list double, that should not complain. Q list double. Wrong name. Okay, now it's fine. Okay, let's run. Okay, something is not working as it should. Let's see here. The socket is defined. We get the data. Okay, this is false. Should not be false. Window log and still compare. If it's 0, then it's the same. Okay, this is fine. This is also true. Minor mistake. Okay. Something's broken since here it does not. It didn't connect. We need to improve on the connection code. Maybe add some recent the connection itself. Okay, but it's always 1, which is boring. Yeah, but we did not implement any additional functionality, so of course the send window is always 1. So now we could add some basic congestion control mechanism. So let's see. How do we do that? So each time we successfully send a package, we want to increase the sending window by 1, and each time we lose a package, we want to halve the size of the congestion window, as I already showed that in this plot last time. So let's see. So where do we grow it best? Well, we can definitely. Well, first we should think about growing. Window increment. Yeah, so if we get an egg package, we should grow it by 1. So what's this? Egg package. So here we have this thing. We look whether we find it, and if we find it, do we want to check that it was only sent once? Nah, let's say if any successfully egged package is enough. So we should also then, but however, have also a limit. But we already have, I think, did we create this congestion window, congestion threshold? Okay. So let's see, congestion window. So if congestion window is larger than congestion threshold, then we can okay, let's make a copy. Shadow ist gleich let's start with this. So if this is the case, then we can we should basically increase that by 1. Or we just go with the cheapest implementation, just plus this, and yeah, why not? Let's just go with that for now. So if this is this, then go with this, and yeah, good. And then we of course need something to. So now if we run it, even if we have packet loss, it will just go bigger and bigger. So we can quickly test that. I'm thinking there is also another error here. We must limit it to the amount of packets that we have in the buffer, so that we never grow it past what fits in our buffer, since that would be not good. Okay, we again drop the connection. Okay, run test. Okay, something's not working as it should. Do we reach? Yeah, we reached this. The congestion threshold was probably set to 1 as well. So let's think about a reasonable value for that as a initial value. Okay, that's the full buffer send size, but that is not. It's not 1. That is 8. That should be working. Or did I did something? Sorry. That the comparison goes in the wrong direction. Plus, we should also check whether so how many packages we have in the buffer. So we should also test if congestion window is smaller m send buffer count or size. Okay. Yes, because we don't want our send window to grow like infinitely if we only have little data in the buffer, because it might cause an error further down the line. So here we limit it to be at most as big as the as the amount of packages waiting to be sent. So now it should, when we start it, probably would be just stuck at 8, since it will very quickly go to 8, and we don't have any resets yet. So before we press the button, it will already during the thing here in the console. Okay, but it's only stuck at 2. Why? Do we have so little packages in the buffer? We don't have enough packages in the buffer, so we need to throw more packages in the buffer. Yeah, that's the only thing we can do. Let's see, server, we will disable this maybe, so it doesn't print. Test server, test client, here we have the delay. We will just reduce the delay. And what else could we change? We had some debugging, debug logs already here. CP trace, and we will disable this since we want maybe all the log to see all the logs. But that will be probably quite spammy, so at least we see that it connected, and when we run it, okay, we only get 3 packages into the buffer now. So let's we managed to get to 4, but I think the better option would be to add some delay to the receiving to the server here, that whenever it receives something, it will just sleep for some time. Is that good? Yeah, that will be a pretty hard rate limiting. So let's go with that. Well, we are at least at 4 packages. Wait, yeah, 5, 6, 8. Well, it works okay-ish. We could add a longer sleep, then we would end up with even more packages here, but this is fine. So now, since we still have the packet loss, we need to add the mechanism which will halve the sending window size. So we had somewhere a recent mechanics. Not here, there. Mm. So let's see, process timer. We only do resends from the timer, I think. So if send time plus this and packet sent is 0. Yeah, so here we only do the resends. So here we want I even put the to do already there. So congestion window size equals well, divided by 2, but it should never fall to 0. So let's go with congestion window size is equals the maximum value of or 1. Okay, so it will always be positive. And now let's see how this will look on our graph. And the idea is that we will then later add sliders so to change the congestion threshold and stuff like that, so that we can see how this behaves. Yeah, okay, well, it dropped only to 3. Why did it drop to 3 and not more? Well, it drops, but it sometimes drops just by 1 click. That is not what it should be. Well, currently it's just running. Okay, and we arrive here for down to 2. And then at some point, where do we grow that again? Zack, zack, zack. And here it will be incremented again. Receive egg package. Okay. Let's go with a much larger value maybe, so that it looks nice. And we definitely need more packet loss. So let's first add more packet loss to the mix, or we actually could already add a additional UI element, since we said we want everything to be configurable. Then here we can add how do we do that best? We could just have a lot of individual entries like label name, label name, label name. Yeah, why not? So this thing goes here. That should be fine later on. And here we will add a let's go with it. Well, we can reuse the same grid layout in principle. So or maybe we should do the grid layout. Yeah, wurscht. Let's go with that. With just using one. I think it's more elegant if we put one layout into the other, because then we will not have to change the parent layout so often. Okay, so label, and we need a line edit. And later we will add more. More labels to this sub layer. Damn it. Okay, that's not so bad to target things. Wait. We can also add labels to the side. Labels to the side. Okay, here we cannot, but here we can. So, and of course then some more line edits. For start, we will only use one line edit, but we will probably add more of them. We could also set add sliders instead, but I guess this is more precise. So we will give a name to the first one. No, we don't need a name, we just need the text. text window limit. This one needs a name. Edit the text. Let's call it text window limit. Okay, this is saved. So let's go to our thing here, and when the button is pressed, then sorry, we did not want to make the window limit. We wanted to make the drop rate. Yeah, let's just create the next entry, so that will be text drop mod, and here just drop something like this. Okay, so now we have everything we will need for now, at least. So here we should compile it once, such that the IntelliSense catches on the new names that we have defined on the UI object. Okay. And we should set the default values. UI dot okay, it does not. Now it should have the new ones. UI.text drop mod set text. We start with 100. UI text when the limit set text. Let's go with 10. I know the default in the other part of the project was 8, but that is fine. Log window will always be set to 1, so we don't have a debug option to change that. That will need to be added. Drop mod text to int, to int actually, to int. Then we need to also set the window option, so congestion threshold. C threshold. Window limit. Let's go with the easier to remember names. Window limit text. Okay, and currently it's such that we need to press the button each time we change something. We might want to improve that by adding a slot for the on-return signal of the text edit, such that if we press enter within one of the edits, it will then automatically apply only this one value. But this is something that can be done later. Okay, so again run test, and let's go with a higher likelihood of package drop. I think the whole thing is too slow because of printing all the debug data. Let's improve on our logging function. Here, where was that? Naming the files too similarly is of course not the best idea. So here currently the way this is implemented, we have the socket, then we have the format and some parameters. I will add a level parameter which will denote the importance of the event. So and here we can then filter if level we have two options: the higher the level, the more important, or the lower the level, the more important the thing. That's pretty much for us to decide now. I would say the higher the level, the less important it is. So like level 1 is the most important stuff and level 10 is the least important stuff. So if level in this case is larger level 1, then return it. Actually I should call that a actually we could make this configurable. Oh yeah, we could. Yeah, but then actually it would be better. Yeah, that is good enough. That makes sense. So if level socket, can we access M? We made M private, didn't we? Okay, we made M protected, but that is that will not be the best. Yeah. So we will stick to that being protected. We'll make a define this as friend, then we can access M. And then we will need to add a parameter to M. Do we have some debug stuff somewhere? Not yet. Okay, so let's make it the first thing of the test stuff all along. You trace level, and we initialize that with 0, of course. Okay. So if level is larger than trace level, then return else log, and then we just need a function to set trace level to something. Oh, and we of course need to define the levels now for every call. So level, well, synac is not very important. Let's go with level. We should define the levels. That is good practice. Trace level. How do we call it? Prime. High is 1, medium is 2, and low is 3, and then that's enough for now. Okay, so synac is sync is high, data is low, and we probably don't have any medium for now. Opcode data arc is also low. This will be a high event. This was already a high event since it's something that should not happen. Too many packet loss. That could be medium. No, let's stay with high for now. Reset is also a high event. This is also synac is also high. Syn is high. Receive. Let's just receive data that's low. Let's just receive. Okay, that's even lower than low. That's just what we do from the lesson. Send new is also low. Low. Send data low. Send arc for data low. And that's it. Okay. Now we need to set this here in our debug option configuration thingy. Trace level. We probably will never use the get function, but it's just good to have it for good measure. And we will set trace level to 2. So when we press start, comma 2. I mean, we don't have medium yet, but if we have it, we probably want to see it. And we well, we could actually make medium events like package loss event. So let's actually add that. So if we resend a package, we'll make a medium level event. Resend package, and we should add maybe another medium level event when we get a duplicate package. That will be process block. Yes, so here if this happens, so it's not in our list, and we add the error here. Duplicate egg received. Send egg package, no. Process egg package. Wait. Process block, oops, duplicate block data. Duplicate data receive. But we also should have somewhere process egg package here where we... Well, that is reasonably cheap. Let's call it just unexpected egg. Unexpected egg received. Yep. Yo, good enough. Let's run. So we should now we could of course also add an event like now dropping a package intentionally or something like that. Of course, that we could do. Run test. Yeah, as you see that things are happening much faster. So here we would need to zoom in, although there is no zooming currently enabled. And each time we okay, not good. We ran into a bug. Block is null. Show we are testing whether block is not null. Well, package. How do we fix that? This is a send instruction. We want to send null. And this is this ping thingy. Here we are sending this empty block. So basically we just put all of that in here. Well, we cannot put all of that. Malloc says so. Actually we need to check whether this is something. So if per block, then size plus equals this. Yep. So we already fixed one new bug. Let's run it again. Okay. I mean, it is apparent that the buffer size... Okay, we have another bug. Okay, we had another block null. Why? Yeah, the same issue. In this case, we should just put this into there. That solves this problem. Jawohl. Yep, okay. So this will fix that issue, and what also we could do, we could add the ability to read out the send and the receive buffer size. So in the size part, count of elements in the buffer. I mean, so let's do that. Or actually, that could be a good homework. Since it's quite easy, because the only thing you need to do is you need to add, of course, a new element, and then the same way as we are reading out here this congestion window log, read out the buffer size. Just thinking about one thing, namely that the way this now works is that we need some event when to sample the data, and currently we are doing it on every try send. But that is not necessarily correct. So maybe it would be good to just use timestamps with some high resolving counter. Then, because the thing is, we will want to probably correlate the results from multiple sockets, or the data from multiple sockets, and they will not at the same time do this. So they will do the things with a certain time delay to each other, and as well different functions will only trigger the update of one value. So ideally we really should go with a high resolving timer and not use this incremental plot actually, but really directly set X and Y data from our from what we get from our sockets, and have this counter which will give us a consistently monotonically increasing time value. That sounds reasonable. So let's do that. I just need quickly to check how to read the performance timers of Windows. That is this is there is a function for that. There is a function for that. Get cocycles. Yes, that's the right one. Or maybe not. Yeah. Okay. So do we have a helper? Actually, we have helpers, but only one which does not implement anything. So let's add here a helpers CPP file, so that we can also have more complex helper stuff. Oops. Yes. Okay. Like with the other ones, we will disable the precompiled headers for this one. Not use. Okay, and our hash include. Let's go with this. Windows H. Cool. That should be defined somewhere in Windows. Okay, it's not. Yeah, this one is at least defined. Nice. Long. This will be the time in microseconds, and that should be probably fine enough. We could also really just stay. Wait, this is not quite correct. We are limiting this far too much. Frequency. No, let's just go with getting the clock counter without dividing it by frequency or anything. Ja, wurscht. Cycle. We can define this, and then here in our we need, however, to define some something other than this for our data. And the simplest way would be std pair long with a ulong. Yep, let's go with that. Okay. And congestion window size will need to be changed accordingly, and whenever we push back, then std make a pair and get cool cycle again cool cycle comma okie dokie. So this works fine. And now we can change our use here, since this will need to change as well. And we don't append, well, and then we said we will not be using the incremental plot anymore. So how much work is that actually? I mean, we only want the constructor thingy. We need plot. We don't need mine. Again, yeah, plots. That is let's do it step by step and see how much we need to add for it to work nicely. So now our plot will be a different thing altogether. Zack. Okay, so we need to create the plot. We can set it here as the new element, style sheets background. We don't really care. Grid on black transparency. It's nice to have a grid, so let's add a grid. Grid has the type we might not need that globally later, so grid pen grid the color, so Qt gray. No, it needs to be a grid. No, it should be gray, fine. Attached to plot, nice. Then auto scale both axes is definitely a good thing. Okay, we don't need anything more, so we have the font is not transparent, so we were in this use case. So let's set this as well before we set the grid. Okay, maybe for the simplicity, Q color, the gray, and then we need front and back. We said front is dark blue. Font. Oh, wait, font. One moment, please. Which so back, front. Okay, back is dark blue and front is white. Okay. And then our add plot. That is complicated things. We'll need to have a variable for every curve that we want to plot. And curve 1. So curve 1 title we don't need. I think it's optional. Yep. Color style. Okay, curve 1. Let's for now make all of the same style. Qt solid line. Why is it complaining? Width 1. I think width was 1 by default. Solid line. So we have the curve. We need to attach it at some point to our plot. Okay, so curve 1 attached to mpeg plot. I don't remember why I did that. Let's just don't. Okay, so we have our curve. And then if we want to add plot points, we will also need something to store the data for it. Well, that had a reason why we created here this structure. So let's copy that structure that is useful. And then we just make like this curve 1. Okay, in this case we have here to change also a few things. Well, curve 1 is new as curve. Did that have any arguments? I think not. Nope. Plot pen attach plot. Oops. Okay, so we were here. We had this init curve. So let's see what this did. Counter limit will be also set. Just initialize it with one empty point. That will need to be improved later on. It's a bit too convoluted if we have multiple entries. Size is 1, counter will be 0, time elapsed, just go with 0 for both entries. I also need this. So let's maybe create a helper function. Add curve, and let's also use this way that allows us to easily configure it later on. So we will copy something from our incremental plot age, add plot in this thingy, so we have already all the variables we want except one. We don't want a name, but we want an ID, since that's much more efficient further down the line. Okay, so this is our add curve, color, pen style. We need to remove the unused what was it? This title. Okay. So we will here with the plot. We then just add curve 0, color qt red, comma qt solid line. That's all we need. And then everything we have here we can for now copy out. Okay, so here we had color, here we had width, here we had style. Okay, small w actually should be big for consistency, and here title. That will be a local copy. Curve, actually it shouldn't be called even curve 1, just p curve. Okay, we don't need the color here. P curve, okay, this is curve data, p curve data. Okay. Why is it complaining? Right, that's the wrong one. Okie, and then we need somehow a way to address those. So let's here create this. We don't need, but we create a Q map with int and a pointer to S curve. Curves or plots. Let's call it plots. Add plot. Okay, add okay, add plot, and here add plots at id is equals curve. So we have this. Good, and here we need to make some add data. Add plot points. Wait. No, that should be fine. Now it's the last valid state. Yeah, that should be a function that is designed to support our format. So let's add here add plot points int id, and instead of double we will go with the type as we get it here from our socket. So this goes here. Suck. Wait, one issue. Okay, add plot 0. No issues. So here just add plot points to 0, and we want to fill it with window lock. And maybe we yeah, good enough. And now we need to fill in this function. Incremental plot. assume that it always exists, so here we will be less careful. And what we will probably also need is this mechanism here to delay the redrawing of the plot, but we will need that only once we have more than one plot. And for now we can ignore that ID. Okay, this is also different curve asterisk. Unless we change everything to work in a similar way, so let's maybe change that. So apparently it was implemented like this before. So curve what is a reference to curve to plots from ID. Let's keep the code consistent between the original code and the new one we create here. And then we don't need that. Nice. Okay, yeah, okay, so limit we don't use. We use the lowercase. Freeze we also don't use. So we only need move by a value. It actually has size, so this is fine. Values. And okay. So x will be the time, first, and well, y will be the second value, the whatever value we have. Yep, that should work. Let's try it out, and then let's plan some homework, since it's time for some homework. The last few lectures was no homework, so it's time for some. Okay, there is. Oops, we have some. Just need to tell it that this is a class type. Since we don't have the includes here, that should be the only issue, hopefully. Yes, that looks promising. Nope. Okay, something's broken, so let's see data. Size value is 4. Size minus. We removed too much code. Actually, the code would actually cause a error here as well. The thing is, we can only move as much as there already is in. So, so int to move should be value size, but if int to move is more than I think here we need to initialize with we don't have get call cycle included here. We need to initialize, otherwise we'll get troubles. Also further down the line, get call cycle. Okay, that apparently was a typo. So to move, we need to check the existing size. Also, we forgot to save the new value, I think. Let's see. Move, and here we do the realloc. Yeah, we will need to start with realloc first, and we don't have a limit value. Ah, damn it. It would be good to have a limit somewhere. I mean, in principle, for now we could just define. Yeah, let's add a limit to the here somewhere. Int limit, set it to 3000 or so. Don't want too many data to be displayed at once. Okay, curve size limit and this. Yep. That should now be fine. Yes, let's see. Okay, okay, it's not working for some reason. Let's see why. Because we don't replot. We forgot. So here we have this delayed replot mechanism, and we need to replot once we change the data. So for now, we'll just add replot to the timer, to the last thing the timer does. And also we can slow down the time. Let's set the timer at something resembling 60 frames per second. So 1000 divided by 60 should give us the roughly right refresh rate for a 60 frames per second display. Let's hope that's the last thing we forgot. Okay, that will need some more debugging. Okay, this one is obviously wrong. But it was working here, wasn't it? Size -1. It was working despite that it probably should not. Since here we always go by -1, but we should count through for the values. So let's here do that properly. Yeah, e is equals null. Or rather, it should not be null, it should be a size, no size, this size. And from which end do we start? We start at the first, so we want to go the furthest back. So minus size, again minus size, and when we are done size, we reduce this by 1. So this is one entry reduce. Yeah, that should be fine. Let's try again. If this doesn't work yet, then I'll just fix it later on before I upload it, since we need to plan some homework. Yep, it's working. The values here, of course, extremely high because it's basically the clock, the computer clock since the machine was booted. But it guarantees us that we will not, that when we record data in different parts of our program, it will all be shown in proper temporal synchronicity. Client buffer full after sending. Okay, something failed in our send mechanics, but that will be a problem for later. We probably dropped too many packages or something like that. Let's quickly try again. And then plan some homework. Yeah. It's working as it should. It always halves the size. and it increases step by step by always by 1 if it works. But apparently there is some deadlock that happens, some missing recent or something, so this will need to be improved, but that is something for later. Now we need to look into homework, and I was thinking that a good task would be to add another plot here with AD1, which will show the round trip time of the packages. So the time a package needs to be acknowledged. Since this probably will be extremely fast on the local host, it will not be very interesting in such a test case. So I will set up later a relay server such that you can send packages to an IP on the internet and get them back at a preset port. But I think we will do that during the next lecture. For now, the homework will be to just add the code to calculate the round trip time, and you can do it with localhost, or you could also do it by adding a random delay when processing a package. So where was that? Here. Receive. So when we have somewhere, oh, it was reds from. So here. Okay, random. It should not be too random. It should be a simulated packet transmission delay, but that's optional, so we don't. So it's not necessary for the task. FTT. Yeah, and this will be now the to do for now. We will want to calculate the round trip time, and we will want to calculate also a variation for the round trip time. So we want to have something that at least resembles a standard deviation. Of course, you can go with the full calculation, but there are a few quite nice tricks how this can be implemented in a way that doesn't require too much memory and keeping past results in memory. So later I will show you how to do it. I just have to see when we will have the next lecture. So let's see. The next lecture is next week. The week after that is a holiday. Okay. That is not the best thing, but I think it should be fine enough. So yeah, let's add the homework. 24/11/2022. Comparable or something comparable for the package for the package round trip time. The RTT. And optional. Optional add a package simulated to sub process. Okay. Okay. Yeah. Sounds easy enough. Any questions? No. Yeah. Any other questions? Okay. So if there are no other questions, then that would be it for today. I will upload the project and the recording as usual. What else? Well, oh, I forgot an important thing about the homework. Add a we want to read that as well. Add a RTT without for get debug data. So and plot it in the main window. So we want, of course, our round trip time to be plotted. So, well, I said it will be a rather boring thing if we don't have the simulator, but the simulator is optional, so we don't have to do that. And another optional thing we could add without for send and buffer for current send and receive buffer CSS. Yeah, well, we want to update it. Update send buffer when adding data as well as when an ACK. Update the file buffer when and when so to make this clear, this is our retsv function. Retrieving from the buffer is done by retsv when update send buffer when adding data. That's our send. And receiving egg was it written like this? More okay. When receiving egg and when receiving data, that will be was it like this? No. Process data package probably. How did we call that? Data process block, just process block. Okay. Process block. Yes, that looks easy enough. So this is this optional thing is really trivial, since you have more or less the whole example already implemented. And here, of course, the calculation part is the most interesting part of the work. The just adding readout will also be quite easy, but it needs to be mandatory since we want to view the result. And of course this well, I should call it optional. Since I already said try to use as little. I mean, try. If you fail, it still but it works. It still works. Of course. So what I mean, the simplest, most trivial way of doing it is to have some list in which you are holding all your samples, and then just computing the average every time from scratch. And of course, this is quite inefficient. There are many ways how you can think about computing some sort of sliding window average in a way such that you will not need to recompute everything all the time. Yeah. So, and of course, one more thing maybe to add is that we don't want the RTT to be like calculated since forever. So the RTT for a limited time window or packet count time window slash and or packet count or it would be weight such that all the RTT samples are irrelevant. Yes, this should be flexible enough that you can do pretty much any implementation you can, and it will somehow work and be okay. Of course, the better it's done, the better it is. Okay, any questions? If not, then that would be it for today. Yes? That would be good, but currently I needed all the time to write the code. If I would write the comments, that would take even longer. But I will try to write more comments in the future, and maybe it would definitely be nice. Just that this project a little bit grew much more than it was initially thought it would grow. I thought it would be much faster to implement all those things one by one, but it showed to be more work than anticipated. But with the remaining things, I will try to comment them more in detail. I could also try to add some more comments after the lecture to the file. That might be helpful as well. Okay, so anything else? Mm-hmm. Yes. So the idea is that the project will be well presented to you during the last lecture in December. And then there are like how many weeks? 1, 2, 3 weeks of holidays, and then 2 more lectures in January. So I will try to present you the project at the 15th of December. And I think it will be reasonable to make it use these things that we showed here. So it will be somewhat network related. One thing I'm thinking currently of would be some sort of simple file transfer application, so that you start 2 instances on 2 computers. You enter one of the instances IP address on the other one, and the file, and press send, and then the file is to be sent to the other computer using maybe our custom protocol instead of TCP. I think this would be reasonably easy to do, and it will need some UI from the Qt part and some networking, so I think it's a good project. Mm-hmm. Mm-hmm. Yeah. Okay. Anything else? Okay. If there is nothing more, then we'll see each other next week. Bye bye.